Hello guys, and welcome back to another episode of chemistry. And today we are going to, of course, chemistry. And we're going to begin with calculations in pH. Calculations in pH. In the previous episode, I have hinted about some formulas that will aid us in solving questions that have to do with what? With pH. And some of them are here, of course. I tell you that pH is what? Negative logarithm to the what? Hydrogen ion concentration. All right. I also told you that this could be what? Or negative logarithm to the hydrozonium ion concentration. This is still valid. All right. And then I told you the relationship between what? Okay, POH also. There's POH as negative logarithm to the what? Hydroxide ion concentration. All right. Or, of course, okay, this could be written in another form, or can have formula as positive logarithm to the what? To 1 over hydroxide ion concentration. All right, 1 over hydroxide ion concentration. Where I told you that this bracket means what? It means concentration, and that is why we pronounce this hydrogen ion concentration. We say this is what? Hydrogen ion. Then what? This bracket is concentration. All right. So aside this, I also give you some relationship between your pH and what? And POH. All right. I told you that pH plus POH is equal to what? 14. All right. And then I also gave you another relationship where I said that the hydrogen ion concentration multiplied by the hydroxide ion concentration is equal to 10 to the power minus what? Minus 14. This is also what? Valid. Now, these formulas are going to be very, very useful while solving what? Questions that have to do with what? With pH. Right? So I expect that you know these formulas handy, because you have to know them handy to be able to apply them. You have to understand and solve a lot of questions with them to be able to know how you can apply them in situations. All right. So now we're going to quickly jump in. Before we continue, know that this video tutorial, of course, is brought to you by the O3Schools JAMB CBT practice app. It is the best CBT app available for you to study. There's a practice mode, there's a study mode, there's an exam mode, there's even a mock mode. You can set questions for yourself and begin to answer as if you are in the exam or live. Meanwhile, the app is available for your Android phone, it's available for the iOS, it's available for what? For your laptops. All right, there's a software for your laptop or your computer at home that you can practice as if you are taking the exam that day. So imagine that you have taken a lot of tests on the app, like your real exam, right? You have prepared yourself. Then when it comes to that day, it becomes easy peasy, especially when all the past questions you ever need are on that app. All right, and there's another wonderful feature you may want to take advantage of, which is the JAMB UTME challenge. It's a challenge that will conduct for all students participating in JAMB for this year, right? So you participate, you win prizes, and you see your score every weekend till 1 week to the exam. Wonderful feature. There's another wonderful feature called the question search feature. That feature enables you, in fact, your assignment on this class right now, I use the question search feature to look for questions that come out under pH, all right, for you to answer. All right, so that feature is a wonderful feature that you can use to practice, to study, and make yourself the best. All right, so activation of the app is 3,000 naira as opposed to 2,500 naira the previous year. Next year it may even go to 3,500 naira or 4,000 naira, I don't know. But right now the activation fee is 3,000 naira. All right, so make sure you download the latest version of the application and begin to practice and see yourself at the top. So these formulas, like I said, will be useful going forward to solve questions under pH. Now let's go to calculations in pH proper. All right, so there are so many things that we need to know when it comes to solving questions in pH. All right, so for example, if I'm given that the hydrogen ion concentration of a solution is, example, by given that the hydrogen ion concentration of a solution is equal to A times 10 to the power minus n. All right. If you are given that the hydrogen ion concentration of a solution is this, A times 10 to the power minus n, we can be able to deduce the pH for this solution, or a value that is very close to it, right? We can be able to deduce a value close to it, or we can be able to deduce what the exact what value. All right, it depending on what the value of what this A. Now, if A is exactly 1, if A is 1, if A is equals to 1, comma, that is exactly 1.00. If it's exactly 1, the pH is equals to N. Just take N as the pH, right? So I'll go over that again. I said if you are given that the hydrogen in your concentration of a solution is A times 10 to the power minus N, right? I said if A is equals to 1, this A here is equals to 1, then that is exactly 1.00, not more than 1.00. Then pH is equals to what? N. Simple as ABC. Let me give you an example. So if I give you that word, that the pH of a solution, that the hydrogen in your concentration of a solution is 1.00 times 10 to the power minus 4, right? And I say find the pH. It's simple. pH is equal to what? It's equal to N, which is equal to what? 4. Because from here, this compare this with what with this. This is A times 10 to the power minus what? Minus N. That means A is what? Is 1 and N is what? Is 4, right? So your pH is what? Is N and it's equal to 4. You see that you don't need to solve at all. That is the first trick to what? Answer questions on pH, right? So if A here is exactly 1, then the pH is equal to what? N. Simple as ABC. But what about if A is not 1? If A is greater than 1, but less than 10, listen, if A is greater than 1, but less than 10, that is A here. If it is less than 1 but less than 10, then the pH is between N and N minus 1. All right, get that clear. Now, the first case, if A is 1 exactly 1, N is the pH. But if A is not 1, right? Let's say A is, for example, 1.69. You will see that what? A is not 1 here. So the pH cannot be N again. So in that case, the pH should be between this value N and N minus 1, right? Out there. So we say if A is greater than 1, but less than 10, the pH is between N and N minus 1. So know that and know peace to start with. Now let me give you an example. So that if I give you what? A question like this, let's say 1.69 times 10 to the power minus 5. All right. Now they say find the word the pH. What will come to your mind first of all is that A is what? 1.69. It is not 1. So 5 is not the pH. But another thing you can know is that what? That N here, what is N? N is equal to what? 5, isn't it? This is N. Then N minus 1, find N minus 1 is equal to what? That is what? 5 minus 1, which is what? 4. That means that the pH is between 4 and 5. It's a value between what? 4 and what? And 5. Because it is not exactly, because A is not exactly what? 1. Because A is what? 1.69. For example, as you are seeing here. So because what? A is not exactly what? 1, then the pH is between what? N and N minus 1. In this case, it's between N, which is 5, and N minus 1, which is 5 minus 1, which is what? 4. So the pH is between 4 and 5. All right. So in an exam condition, you are given something like this, you say find the pH. Even if you do not have complete time to what? To look for the pH, right? You can deduce, you can, from the options, you can quickly know what the answer is. Let's say in the options, there's let's say A is what? For example, 6.31. B is 4.52. C is, I'm not saying these are the answers. So I'm just saying that, let's say, for example, now, right? Then C is, for example, 6. Okay, let me say 3.31. Then D, for example, is 5.52. Right? They say what is the pH of what? Of a solution having hydrogen in your concentration of 1.69 times 10 to the power minus 5. You should already know from here that what? That the pH is between 4 and 5. And the only option that has 4 is what? That the only option that has an answer that falls between 4 and 5 is what? Option B. So you don't even need to over solve anything again. You already know. So because of that, you can deduce that that will be the pH, because the answer is the value is between what? 4 and what? And 5. All right. So that what I'm trying to portray to you is that when A is not 1, the pH is between n and n minus 1. So in this case, it's between what? 4 and what? And 5. All right. So now, but of course, we need to do further. We need to further solve to get the actual what? Value of what? Of the pH of the solution. We have to actually solve, right? From here, we're not going to end there. We're going to actually solve to get the actual what? Value of the pH. So just know those two things. When A is 1, and when A is exactly 1, n is the pH. But when it is not, it is between n and n minus 1. So let's take an example to drive this point home. Take an example to drive this point home. All right. So if I give you now an example, they say determine the pH of 4 different solutions. All right. Let me take that down. Determine the pH of 4 different, let me say four different solutions, right? Given that what? Given that the hydrogen ion concentration is A, the first one is 1.0 times 10 to the power minus 3, right? Are we there? Then B, the second one is 1.0 times 10 to the power minus 9. Then the third one, C, is 1.79 times 10 to the power minus 8. Then D is what? 5 times 10 to the power minus what? 9. All right. So before we solve this, there's something I need to quickly what? Explain to you. So for example, we already know that what? That pH is negative logarithm to the hydrogen ion concentration. All right. So if, for example, if the hydrogen ion concentration is what? A times 10 to the power minus n, then of course, that we can replace hydrogen ion concentration with this. So I'm going to have what? Minus log of what? A times 10 to the power minus what? Minus n. All right. So if you know the laws of logarithm, it will be easy for you to what? To follow up this easily. But if I have not learned about logarithm before, there's a video on this channel that basically and simply explains what logarithm. So please look for it under the mathematics channel and watch it. All right. So I'm going to have this will be the same thing as what? Negative into log of what? Of A, then plus what? Log of 10 to the power minus what? N. This is base 10, of course, and this is base 10. All right. So now remember we told you this is how we break down this. For those chemistry students, for science students that do not know mathematics, please, it is important you know mathematics. All right. So breaking this down from the laws of logarithm, multiplication, when there's a multiplication sign here, it means that what we're going to what? We're going to add. So log A, we can break this to log A plus log 10 to the power minus n base 10. This is base 10, base 10. All right. So having done this, now we are told that what? When A is what? We are told that when A is what? Is equal to 1, the pH is equal to what? Is n. That means n is the pH when A is equal to 1. All right. So we'll get there. So now let's get there. If we put 1 here, we're now going to have negative into logarithm of 1 base 10, log of 1 base 10, then plus. Now, this minus n can come down. It will come down. I'm going to have minus n log 10 base 10 from the law of logarithm also, right? If a number is raised to power, right, and is in a logarithm, we want to bring that power down back to the back of the logarithm, and then we'll now have what? The number base the other number. All right, so that's what we just did here. We brought this n to back of this logarithm minus n log 10 base 10. All right, so now, and in logarithm, lots of logarithm also, if I have logarithm of 1 to any base, is 0. So this one is automatically was 0. So I'm going to have minus 0. Then plus times minus is what? Is minus. Plus times minus is what? Is minus. All right. Minus n. Anything based anything logarithm of a number to any base. Logarithm of a number to any base is 1 in the laws of logarithm. You guys are making this difficult for me, all right? Because I'm not teaching maths, I'm teaching chemistry, and I'm trying to make you understand, right? So please go and watch that. I taught the logarithm. So please go and look for that video. I'll try and pin it under this video. I'm going to pin it under this video for you to be able to follow through with watch it, understand it, then come back to solve all this question. So I have 0 minus n minus n, then log 10 base 10 is 1, n times 1. All right, so I'm going to have, right, that's I'm going to have minus 0 times 0 minus anything here is going to be 0. So into minus n. So minus times minus is plus, which is equal to n. Remember, this is pH. This is pH. This is pH. Negative logarithm to the hydrogen ion concentration. This is the concentration. Hydrogen ion concentration is A times 10 to the minus n. So this is pH. So it's pH. So this is pH. All right. So I'm just trying to show you the proof of how we arrived. There's a new formula I want to introduce to you. I'm trying to show you how we got there. All right. So now we give that pH is equal to now? N, when A is equal to 1. Because what we did there was to substitute 1 for A to get this value. That means pH is equal to N when when A is equal to 1. So the new formula that now comes to play is that pH is equal to N minus log A. Right? This will work. This will be very, very correct, because if you put 1 here, pH will be equal to N minus logarithm of what is A? 1 base 1 base 1 base 10. Logarithm of 1 to any base is 0. So I'm going to have pH is equal to N minus 0 and pH is equal to N. So this formula is valid. Is valid for pH, for solving questions in pH. That formula is very, very, very valid anywhere in the world. All right. So we're going to keep this to heart. I'm going to use it to solve a number of questions. All right. So aside this, another thing we still need to know is basic log of some common numbers, of some simple whole numbers. Logarithm of some simple whole numbers. For example, logarithm of 2. Logarithm of 2 to base 10 is 0.3010, right? Logarithm of 3 to base 10 is 0.4771, right? Logarithm of 4 to base 10 is 0.6020. Logarithm of 5 to base 10 is 0.6990. Logarithm of 6 to base 10 is 0.7781. So it is expected that you know these common logarithms. All right, they are common logarithms. If you did logarithm in your secondary school, right, there's no way that you have not encountered this. If you solve a lot of questions, there's no way you don't have them on your upstairs. So make sure you know what these common logarithms. All right, but they will help us going forward to solve questions. All right, now let's go ahead and answer these questions now that we have known that formula. Okay, so now determine the pH of 4 different solutions, given that the hydrogen ion concentration for the first one is 1.0. For A, you are given that hydrogen ion concentration is is 1.0 times 10 to the power minus 3. Now we already know that when A is 1, it's exactly 1. The pH is is N. So from here, A is is 1, N is is 3. That means that pH here is equal to 3. All right. So you may want to also use your formula where we say pH is equal to N minus log A. All right. Now pH, because of what is N? N is 3. Then minus log of A is A is 1 here, right? 1.0. So I have 1 base base 10. All right. So if you do that, we want to have pH 3 minus log 1 base 10 is is 0. Anything logarithm of a number to any base is 0 from the rules of logarithm. So 3 minus 0 is is 3. It's very simple. You get. So in case you do not want to solve, you have already seen that this is already 1.0. Just know that the pH is is N, which is 3. All right. Let's see the second question. Same thing as the second question. We're given that the hydrogen ion concentration is 1.0 times 10 to the power minus 9. All right. So from here, I already know that the pH is is 9, because A here is A is 1, right? So there's nothing to solve here again. A is already 1. That means the pH is is 9. Okay, now that I've known that, let's see the third one. C, we're given that what? That the hydrogen ion concentration of this one is what? 1.79 times 10 to the power minus 8. All right. So this is different from the one we have been doing, the first two we have done, because the A here is what? 1.79, and N here is what? Is 8. Now, we already know that what? When A is not exactly 1, when A is a number greater than 1 but less than 10, then we know that the pH is between N and N minus 1. N is 8, N minus 1 will be what? 8 minus 1, which is what? 7. That means the pH is between 7 and 8. The pH is between 7 and 8. Between N, 8, and N minus 1, which is what? 7. Hope you are there. So now, having known this now, then we need to what? Continue what? Solving, right? So now let's see what we can do. Now that we know that what pH is between N and N minus 1, now we can use our formula also, that what? pH is what? N minus what? Log A. All right. What is our pH? pH is what? We're giving pH now, I'm not giving pH, I'm looking for pH. So I'm giving that pH, because what is N? N is 8 minus what is now look for what? Log. What is A? A is what? 1.79. All right. So now from here, we need to look for logarithm of 1.79 minus 8. So I'm going to have pH is equal to 8 minus, what is log of 1.79? Press your calculator, right? From what I've solved here, log of 1.789 is what? Is 0.252. So that our pH now will be 8 minus 0.252, which is 7.75, which is what? Between what? Between 7 and 8. See the value, 7.75, which is between what? 7 and what? And 8. It's as simple as ABC. So solving questions on pH is very easy. All right, it's very, very easy. We're going to see the past question, the questions on the O3 Schools JAMB that have been said by JAMB. You will see the way they said that question. It's not much more different from this. All right, now we're going to continue. All right, let's see the last one, D. D here, the hydrogen ion concentration is given to be what? 5 times 10 to the power minus what? 9. All right, so we can just use our formula. pH is equal to N minus log A. What is N? N is 9 minus what is log? What is A? 5. That is log what? Log 5. We know log 5 to be equal to what now? 0. What? 0.6990. All right, so we can now what? Continue. I'm going to have 9 minus what? 0.6990. All right, so that our answer there will be what? If you do that, I'm going to have 8.301. The answer, if you see between what? Is between what? 9 and 8. Because here, our N is 9 and our N minus 1 is what? Is 8. That is 9 minus 1, 8. So our answer is valid, 8.301. So this is one way JAMB can set question for you on what? On pH. Right? You'll be given the hydrogen ion concentration and be told to find the pH. Other times you'll be given the pH and you'll be told to find the hydrogen ion concentration. So whichever way, if you understand this, right, the next part of calculation will not be difficult to understand. So let's quickly head back to that. All right, now, so let's take some other examples. Another different type of way questions can be set under pH. All right, we're done with that first part. Okay, so now we'll be given that, for example, we have a question here. That's example 2 now. They say determine. I'm going to make this part fast so that you can quickly join me. Determine the All right, so welcome back. Now, we're giving the question, but say determine the pH of the following solution. A solution of ACl with, we are giving the hydroxide ion to be what? 2 times 10 to the power minus 7. All right, so from here, there are so many ways we can solve this, right? By giving the hydroxide ion, right, that means we can find the pOH. If we find the pOH, then we can subtract it from 14 to have the pH. Or we can also say that, well, let me draw this into 2 so that I can see clearly. Now, from here, the first approach. So let me say solution. So for the first approach we are going to use, All right, we are going to look for the pOH because we are giving the hydroxide ion to be equal to what? 2 times 10 to the power minus what? 7. All right. Then we can look for the what? For the pOH. pOH is what? Negative logarithm to the what? Hydroxide ion concentration. You see the same thing. All right. That means that what? pOH also is equal to what? N minus what? Log A. All right. So what is A? A is 2. A is what? Is 2. N is what? Is 7. All right. Obviously, you already know that what? From here, our N minus 1 will be equal to 7 minus 1, which is 6. That means our pH is between 6 and 7. Whatever answer we should have should be between 6 and 7, should not be less than, should not be greater than. All right. So this will serve as a guide for us. Now, let's go. What is N? Our N here is what? Our N is 7 minus log A. Log A, that is log what now? Log 2. A is 2. So I'm going to have 7 minus what? What is log 2? 0.3010. All right. So if you subtract, the answer should be what? 0. I guess 0.6990. Sorry, 6.6990. 7 minus 0.3010 is 6.6990. All right. So having gotten that, we have gotten our pOH to be this. Now we know from our formulas that what? That pH plus pOH is equal to what? Is equal to 14. All right. Remember? All right. So pH now will be equal to 14 minus pOH. Make pH the subject here. pH comes here. pOH goes the other way. 14 minus pOH. So that pH is equal to 14 minus 6.6990. If you subtract that, I think you should get a value called 7.301. All right. So that will be our answer. So our answer is what? 7.301 when we subtract. So you see, are we within the right frame? We are, because we said our value, our pH is between what? First of all, this one is correct. It's between 6 and 7. Our pOH is between 6 and 7. But pOH here is different because the pH here is different. We're having 7.301 because we're not giving the hydrogen ion concentration in this question. We're giving the hydroxide ion concentration. So this guide helps us to this point, right? Then it's just to subtract 14 from what? From the pOH to get the pH. All right. So that is very, very correct. That is the first approach. The second approach I'm going to use, remember we said that hydroxide ion concentration times the hydrogen ion concentration is equal to 10 to the power minus what? Minus 14. All right. So we can use this second approach also to solve the question. So what do we do here? Hydroxide ion concentration is what? They're giving the hydroxide ion concentration to be 2 times 10 to the power minus what? 7. All right. Then times we're looking for hydrogen ion concentration. So this will give us what now? 10 to the power minus what? Minus 14. Then that means if this is to go this way, right? If this to stay here, this has to go this way. So the hydrogen ion concentration now we are looking for is what? 10 to the power minus 14 divided by 2 times 10 to the power minus what? 10 to the power minus 7. All right. Then we can break this. We can bring this 1 over 2 out. 1 over 2 times 10 to the power minus 14. If this minus 7 is coming up, it turns to plus 7. Get it? So 1 over 2 is what? 0.5. So our value here, 1 over 2, 0.5 times 10 raised to the power minus 14 plus 7 is what? Is minus 7. Minus 7. All right. Now, having gotten this, what do you do next? We have to make this what? In standard form. We need to apply our knowledge of standard form so that 0.5 times 10 to the power minus 7. I've said too many 10 to the power, so please, the thing is actually changing to another thing in my mouth. So 0.5 times 10 raised to the power minus 7 will be equal to what? 5.00 times what? 10 raised to the power minus 8. All right, in standard form, because you are bringing this point forward. You are add what? Add what? Negative 1 to the power. All right. So this is now our what? This is now our hydrogen ion concentration. So to find the pH will not be difficult again. So pH is equal to N minus log what? N minus log A, which is what? N, which is what is N here? Our N is 8. Our N minus 1 is what? Is 7. That means our pH that we should get should be between 7 and 8. So now let's subtract. We're going to have N is what? 8 minus log A is what? 5 minus log 5, which is what? 8 minus what? What is log 5? 0.6990. So if you subtract, I think that should give you 7 point what? 301. All right. So that is very, very, very what? Easy. You see the two approaches we use. Because we are given the hydroxide ion, right? We first of all found the pOH, then subtracted it from the pH, right? The second approach, we use our formula we're given. Hydroxide ion times hydrogen ion concentration is equals to what? 10 raised to the power minus 14. Then we'll just what? Collected like 10 and substituted, and then we found the hydrogen ion concentration. Then from there, we'll look for the what? For the pH. So all the formulas we gave from the beginning of this class are very what? Relevant to what? Solving questions on that what? pH. Okay, now that I've seen that, let's see the other part of the question. That is the first question. Now the second one said, determine the pH of a 0.002 molar solution of hydrochloric acid. We are given the concentration of the acid, right? We are given the concentration of the acid, and we're told to find the what? To find the pH. So what do we do? Very easy. Now, another formula comes to mind. All right, please do not be scared. Formulas, a lot of formulas are here, but they are all easy to memorize. All right, so hydrogen ion concentration, a new formula, hydrogen ion concentration is concentration of acid times basicity. All right, concentration of acid times basicity is hydrogen ion concentration. Hydrogen ion concentration on the other hand is what? Concentration of base times acidity. All right, so in the previous episode, we have talked about what? Acidity and basicity, isn't it? Now we say basicity is the number of what? Replaceable hydrogen ions that can be found in the molecular formula of a compound, right? While the acidity is what? Number of what? Replaceable hydrogen ions that can be found in the molecular formula of a compound. Please, that's why every episode is important. Do not skip any of them, right? Do not skip any episode for whatever reason. So please go back to the previous episode, watch everything up to this point. They are all important because you don't even know where your question will come from. All right, so now, having known that now, then we can now use this word to look for what? For the pH. That means that what? That pH on that hand will be what? Negative logarithm to what? Concentration of acid times basicity. All right, concentration of acid and basicity. While pOH will be equals to negative logarithm of what? Concentration of base times what? Acidity. All right, so that will be what? Valid also. Okay, now having known this now, then let's continue. Now we are given the acid here, a solution of HCl. What is the basicity of HCl? Basicity of HCl here is 1 because it only has what? 1 hydrogen ion in the formula. All right, so to find the hydrogen ion concentration of this HCl now will be what? The concentration, which is 0.002, right? Then multiply by what? By 1, which will give us 0.002 still. All right, so by giving this as the hydrogen ion concentration, we can convert this to standard form. That will give us 2 times 10 to the power minus what? Minus 3. So this is standard form. If you don't know standard form, please, there's a topic on standard form in mathematics. We have dealt with all topics that has to do with JAMB in mathematics. Please go watch and learn. Okay, then let's head on. Now that we know the hydrogen ion concentration, then what do we do next? Okay, we are told to find the pH. So looking for the pH will not be difficult any longer because we know that what? pH is what? N minus log what? Minus log A. So the only trick here, the only problem here is to know this formula. Say, okay, so let's go. What is N? N is what? Yeah, N is 3 minus A is what? 2 log 2. That means 3 minus what? What is log of 2? 0.3010. So if you subtract, you are going to have your answer to be what? Let me check. I solved that before, so I do not want to waste too much time on it. So I'm going to have 2.699. All right, so that will be what? Your value. All right, are we there? So now let's see the other question. they say a 0.000 B, a what? 0.00005 mole of what? Of CaOH2. So this means that our hydrogen ion concentration because to what now? 2 multiplied by 0.00005. All right. So that will give us 0.0001. Okay. So we can convert this value to what? To standard form. That will give us what? 1 times 10 to the power 1, 2, 3, 4 minus 4. All right. So simple as ABC. Now that we know our hydroxyl ion concentration, we can look for the pH. Remember, we are not asked to look for the pOH here. We are told to what? To look for what? Determine the pH of the solutions. It's pH you're looking for. So you said that here we'll look for the pOH first, then subtract from 14. That will work. Or we can use that formula also that says hydroxide ion concentration times the hydrogen ion concentration is equal to 10 to the power minus what? Minus 14. All right, this can work. So, but first of all, let me look for the pOH. pOH is easy to look for because A is 1. That means pOH is what? Is 4. Isn't it? Because when A is 1, pOH is what? Is N, which is 4. So now that means our pH will be equal to 14 minus what? 4, which is what? 10. Simple as ABC. All right, so this is another format they can use to set question for you. It's as simple as ABC. Just know this formula. Concentration of acid times basicity for acid, then concentration of base times acidity for what? For the base. All right, it's as simple as that. Okay, now we're now going to also move on to another way they will set question. In this part, you'll be given the word the pH and you'll be told to find the hydrogen ion concentration. All right, so let's head on. Let's solve another question to bring that point home. And of course, I'm going to also make this part very fast so that we just start solving. All right, you're welcome back. Now, in this part of the question, we're told we're given the word the pH value for the solution, and then we're told to what to find the what the hydrogen ion concentration. So, like we are reversing the order, isn't it? So it's also easy. So please bring your mind down. The formula that will be very helpful here. So let me say solution first. The formula that will be very helpful here is our what? Our normal formula. pH is equal to what? N minus log A. All right. So we already know in the question, right? If the pH you are given is a whole number, if it is a whole number, you know that what A is 1, isn't it? It's just common sense. A times 10 to the power minus N. We say that what when A is what? 1, pH is what? Is N. So if the pH is an whole number like this, for example, A is 3.0, right? For like this first example where A is 3.0, know that what? That that A is what? Is 1. That is why the pH is what? Is 3. So we can easily deduce our what? Our N, right? And our what? Our hydrogen ion concentration from there. Very simple. All right, now let us all head back to it. Now, most times our A, looking for our A may be the problem, especially when A is not equal to 1 or when the pH is a decimal number like this. So you already know that what A is not 1. For it to be decimal, that means it's in between two numbers, isn't it? Exactly. So that is the only knowledge you need. When A is what? It's a decimal number, know that what when the pH is a decimal number, know that what A is 1. But when A is a decimal number like this, you know that what that A is what is going to be what decimal also, right? Because A is not exactly 1. That is why they're having what in between values. All right. So now let's just quickly head to that. Now we can find what A equals to what log inverse of what N minus pH. All right. So just note this, right? Because the inverse of what of log is what is what make us what to be able to know the value of what of A. Because from here, for example, let me write it out pretty well out so that you understand. Because from here, log A because of what N minus what pH. Because pH is coming this way, log A is coming this way. All right. So, but it's not log A we are looking for. We're looking for A. Most times A we are looking for. That is our concern. So that what A now because of log inverse. From your calculator, press log inverse, right, of N minus what N minus pH. You get what your answer. You get your A, and then you're able to know. Obviously, you have known your N already, isn't it? Okay, it is easy to know N, but it's not easy to know A. All right. So from that first example, let's solve now. On that first example, for the first one, they say on A, they're given that what that the pH is equal to what? 3. Right? If the pH is equal to 3, right, it simply means that what? That our A is 1. All right. So that what? Our N is what? Is 3. So that our hydrogen ion concentration because of what now? A, which is 1, then times what? 10 raised to power minus what? Minus 3. Simple as ABC. That part is that is the easiest part because it's a what? It's a whole number. Now, for the second part, where we need to actually sweat a little, pH is equal to 3.30. So in this case now, pH is a decimal number. That means our A is not 1, right? But we know that what? That this pH is between what? 3 and 4, isn't it? It's 3.30, not between 3 and 4. That's the only thing you need to reason out. So this is between 3 and 4. And that means that what? That N is what? Is 4, comma, N minus 1 is what? N minus 1 is 4 minus 1, which is 3. Right? Simple. So we know our N to be 4. We know our N minus 1 to be what? To be 3. Right? So that means if we know our N, already, then what is left for to what? To find out what? Our A. Right? So can I use our formula? We say that what? Log of A, we say that what? That A is equal to log inverse of what? N minus what? pH. All right. Why? Because we know N, we know pH. We're looking for A. That's how we can use this formula. That's why it's very valid. This was coined from what? pH is equal to N minus what? Log A. So we coined this from this. We just made A the subject of the formula here. All right. So now using this, I'm going to have our A is equal to log inverse of what is our N? Our N in this first example is what? Is 4 minus what's our pH? pH is given to what? 3.30. All right. So A is what? Log inverse of what? 0.7. All right. So if we do that, our answer will be equal to what? Our A will be equal to what? 5. Simple as ABC. Because anti-log of what? 0.7 is what? Is 5. Although I said the question, what logarithm of what number will give me 0.7? Is of course 0.699. That is what log 5. Log 5 will give us 0.6990, which is exactly the same as 0.7. So that will be 5. So we know our A, we know our N. So our hydrogen ion concentration will be very easy to find now. So the hydrogen ion concentration is equal to what now? Our A, which is 5, times what now? Times 10 raised to power minus, what's our N? Our N is 4. Simple as ABC. So we can actually look for what? For the hydrogen ion concentration when we know the pH. Or the first thing we need to know is what? Is know our A. Once we know our A, and first of all, to know our N. Because from the pH, you can be able to deduce where the N will fall at. You said that in between, it has to be in between the number that's given, the pH value that's given. It has to be in between the pH value that is given. That's why for 3.30 is between 3 and 4, right? So that our N is 4, our N minus 1 is what? Is 3. Remember when I told you that what? When A is not what? 1, pH is between N and N minus 1. All right, so that's the first example. Now let's see the second example to drive this point home. All right, and then we'll go to another part of it. So now we're given that pH is what? That is C now. pH is 11.70. 11.70 is between what? 12 and 11, right? This means that what? Our N is what? Is 12. Our N minus 1 is what? 12 minus 1, which is what? 11. That is the first thing you need to first of all look for. So once we have known that, we can know that our what? Our log A is what? Sorry, that our A is what? Log inverse of what? N minus what? pH. All right. So what is our N? Log inverse of what? What's our N? N is 12 minus what is our pH? 11.70. So I'm going to have log inverse of 12 minus 11.70 is what? 0.30 0.30, right? So of course our A now will be equal to what? Log inverse of 0.30 is what? Is 2. If you ask yourself the question, logarithm of what number will give me 0.30? Is logarithm of 2. So we know that 2 is A. Then our hydrogen ion concentration will not be difficult to know any longer, because that will be equal to what now? 2, that is A, times what? 10 raised to the power minus, what's our N? Our N is what? Our N is 12. So simple as A, B, C. All right, we take a fourth question now. All right, so in this situation, it's as simple as what we have been doing anyway. So now we're giving the pH of the soft drink. We are told to find the what? To calculate the pH of the drink. All right, so solution, pOH is what? 10.60. pH is what we're looking for. It's unknown. We know that what pH plus pOH is equal to what? 14. Excuse me. So then, if you know pOH, we just apply our formula there. So pH now, because of what? 14 minus pOH. So that will give us 14 minus 10.60, and that will give us 3.4. All right. So that will be our pH. Simple as ABC. Now, the other part, they say look for the hydrogen ion concentration of the soft drink. All right. Since we know pH, since you know the pH, we are told to what? Look for the what? Hydrogen ion concentration. That will be very easy. So the first thing we need to do is to know that what? 3.4 is between 3 and what? 4. That means our N is equal to 4. Our N minus 1 is what? 4 minus 1, which is what? 3. All right. So then we can now proceed with our calculation. Then we then need to look for what? Look for A, isn't it? So A is what? Log inverse of what? N minus what? pH. Then what is log inverse of what is N? N is 4 minus what is the pH? pH is what? 3.4. All right, so I'm going to have log inverse of 4 minus 3.4 is what? 0.6. Log inverse of 0.6 is, of course, is equals 4. So our hydrogen ion concentration will be equals to what now? A, which is 4, times 10 raised to the power minus N, which is what? 4. Simple as ABC. All right, so we'll take the last question and then we'll call it a day. I'm going to what? You're going to see the assignment on your screen immediately after the last question. So please do not hurry to what? To skip any of it. So let me make this part fast so that we just write the question on the board and then we solve it. All right, so in the last question, that is number 5 now, I guess. They say calculate the pH of seawater given that its hydroxyl ion concentration is 5 times 10 raised to the power minus what? Minus 4. All right, so we're giving what? The pOH. By giving the what? The pO, so the hydroxyl ion concentration, I told to calculate the what? The pH. It's as simple as ABC. So from here, there are two approaches you can do to find what the pH, but let us take the simpler approach. All right, so since we know that what hydroxyl ion concentration is equal to what? 5 times 10 to the power minus 4, right? Then we can find the pOH. All right, pOH is what? Of course, it's as simple to find because we already know, we know A, right? We know what? N. N is what? 4. A is what? Is 5. All right, that means that what? Our pOH will be between what? Will be between N, which is 4. N is 4. And N minus 1 is what? Is 3. That means our pOH is going to work 4 within what? These two what? Limits. All right, then. So then how do we now get our what? Our pOH? Our pOH is equal to what? N minus what? Log A. Isn't it? So what is our N? 4 minus what is then log what is A? 5. So I want to have 4 minus what? Log 5 is what? 0.6990. That will give you 3 point what? 301. So that's our pOH. But we are not looking for pOH. Remember, it's pH we are looking for. All right, so pH also plus pOH is equal to 14. So that our P is equal to what? 14 minus what? POH. That is 14 minus 3.301. Our answer will be what? 10.70. All right, so it's simple as ABC. So we'll be applying the same thing we're doing to what? To answer questions. And your assignment is showing on the screen right now. Please go to the O3Schools Past Question JAMB app, download it, activate it with 3,000 naira to access all the features and all the questions on the app. It's a one-time activation fee, and then search for those questions and solve all of them. Anyone you do not have anyone have issue with, this is our WhatsApp number for chat: 09121515246. Please, if you have not given this video a like, what you are doing is wrong. Click on that like button. If you have not subscribed to this channel, subscription is free for this channel. So click on that red subscribe button so that once we publish a new video, you'll be among the first to know. And then, of course, do not forget to share this video to your friends and loved ones. And I'll see you in the next class. Thanks for watching.